Introduction. Hey Priya, what are you doing with these sticks?
I'm making different shapes using these sticks. See, I have made a parallelogram.
This is good. Can you now make a triangle?
I can make, but I'm left with only 2 sticks now.
No problem, you can still make a triangle.
But how?
Give me the sticks.
See, now both the shapes have the same base. This was so easy. Come, I will tell you more about such figures.
Objectives. At the end of this lesson, you'll be able to draw the figures on the same base and between the same parallels, understand the parallelograms on the same base and between the same parallels, understand the triangles on the same base and between the same parallels, prove the theorems related to the areas of parallelograms and triangles, and solve examples related to the areas of parallelograms and triangles. Definitions. Students, the magnitude or measure of the planar region is called its area. And do you know what a planar region is? The part of the plane enclosed by a simple closed figure is called a planar region corresponding to that figure. Two congruent figures have equal areas, but the converse is not true. The area of a figure can also be denoted by AR. For example, area of triangle ABC can also be written as ARABC. Figures on the same base. Look at this figure. We have got 2 figures here, a rectangle ABCD and a parallelogram CDEF. We can see that both the figures are on the same base CD. Similarly, in this figure, triangle ABC and triangle BCD are on the same base BC. Now look at this figure. Here a triangle ECD and a parallelogram ABCD are on the same base CD. Figures on the same base and between the same parallels. Now look at this figure. We can see that parallelogram ABEC and the parallelogram ABFD are on the same base AB. Also, the vertices CE of the parallelogram ABEC opposite to AB and vertices D and F of the parallelogram ABFD opposite to AB line on the same line CF, which is opposite to AB. So we can say that both the parallelograms lie on the same base AB and between the same parallels AB and CF. Similarly, in this figure, the triangles ADB and ACB both lie on the same base AB and between the same parallels AB and DC. So we can say that the 2 figures are said to be on the same base and between the same parallels if they have a common base side and the vertices or the vertex opposite to the common base of each figure lie on a line parallel to the base. Parallelograms on the same base and between the same parallels. Theorem. Parallelograms on the same base and between the same parallels are equal in area. Let us prove this theorem. Proof. 2 parallelograms ABEC and ABFD on the same base AB and between the same parallels AB and CF are given. We need to prove that area of ABEC is equal to area of ABFD. In triangle ADC and triangle BEF, angle ACD is equal to angle BEF because these are corresponding angles from AC parallel to BE and transversal CF. Mark it as 1. Angle ADC is equal to angle BFE because these are corresponding angles from AD parallel to BF and transversal CF. Mark it as 2. Therefore, angle CAD is equal to angle EBF, angle sum property of a triangle. Mark it as 3. Also, AC is equal to BE, opposite sides of the parallelogram ABEC. Mark it as 4. So, triangle ADC is congruent to triangle BEF by ASA rule using 1, 3 and 4. Therefore, area of ADC is equal to area BEF because congruent figures have equal areas. Mark it as 5. Now, area of ABEC is equal to area ADC plus area ABED. Now we know that ADC is equal to BEF, therefore we can write it as area ABEC is equal to area BEF plus area EDAB from 5, which is equal to area ABFD. So, parallelograms ABEC and ABFD are equal in area. Converse of theorem. So we have proved that the parallelograms on the same base and between the same parallels are equal in area. The converse of this theorem is also true, which says that parallelograms on the same base or equal bases and having equal areas lie between the same parallels. Example. Let's prove an example now. If a parallelogram and a triangle are on same base and in the same parallels, the parallelogram is double the triangle. Let the parallelogram ABCD and the triangle EBC be on the same base BC and in the same parallels AE, BC. Then the parallelogram ABCD is double the triangle EBC. Construction. Draw AC. Since AC bisects the parallelogram, therefore the parallelogram ABCD is double triangle ABC. But triangle ABC is equal to triangle EBC because they are on the same base BC and in the same parallels AE, BC. Therefore, parallelogram ABCD is also double triangle EBC, hence proved. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at O. Prove that area of triangle AOD is equal to area of triangle BOC. Solution. It can be observed that triangle DAC and triangle DBC lie on the same base DC and between the same parallels AB and CD. Therefore, area of triangle DAC is equal to area of triangle DBC, which implies area of triangle DAC minus area of triangle DOC is equal to area of triangle DBC minus area of triangle DOC, which implies area of triangle AOD is equal to area triangle BOC. Triangles on the same base and between the same parallels. Theorem. Two triangles on the same base or equal bases and between the same parallels are equal in area. Given two triangles ABC and DBC on the same base BC and between the same parallel lines BC and AD. To prove, area of triangle ABC is equal to area of triangle DBC. Construction. Through B, draw BE parallel to CA intersecting DA produced in EVV, and through C, draw CF parallel to BD, intersecting line AD produced in F. Proof. We have B parallel to CA by construction. BC parallel EA. This is given. Therefore, quadrilateral BCAE is a parallelogram. Similarly, BCFD is a parallelogram. Now, parallelogram BCAE and parallelogram BCFD are on the same base BC and between the same parallel lines BC and AD. Therefore, area of parallelogram BCAE is equal to area of parallelogram BCFD. Mark it as 1. We know that the diagonals of a parallelogram divide it into two triangles of equal area. Therefore, area of triangle DBC is equal to area of half of parallelogram BCFD. Mark it as 2. And area of triangle ABC is equal to area of half of parallelogram BCAE. Mark it as 3. Now from 1, area of parallelogram BCAE is equal to area of parallelogram BCFD, which implies that half of area of parallelogram BCFD is equal to half of area of parallelogram BCAE. Hence, area of triangle ABC is equal to area of triangle DBC. The converse of this theorem is also true. It says that two triangles having the same base or equal bases and equal areas lie between the same parallels. Example. In a triangle ABC, E is the midpoint of median AD. Show that area BED is equal to 1 upon 4 area of triangle ABC. Solution. Given that AD is the median of triangle ABC, therefore, it will divide triangle ABC into two triangles of equal areas. Therefore, area of triangle ABD is equal to area of triangle ACD, which implies that area of triangle ABD, which is equal to 1 upon 2 area of triangle ABC. Mark it as 1. In triangle ABD, E is the midpoint of AD, therefore BE is the median. Therefore, area of triangle BED is equal to area of triangle ABE, which implies area of triangle BED is equal to 1 upon 2 area of triangle ABD, which implies area of triangle BED is equal to 1 upon 2 into 1 upon 2 area of triangle ABC from equation 1, which implies that area of triangle BED is equal to 1 upon 4 area of triangle ABC. Show that the diagonals of a parallelogram divide it into 4 triangles of equal area. Solution. We know that diagonals of parallelogram bisect each other. Therefore, O is the midpoint of AC and BD. BO is the median in triangle ABC. Therefore, it will divide it into 2 triangles of equal areas. Therefore, area of triangle AOB is equal to area of triangle BOC. Mark it as 1. In triangle BCD, CO is the median. Therefore, area of triangle BOC is equal to area of triangle COD. Mark it as 2. Similarly, area of triangle COD is equal to area of triangle AOD. Mark it as 3. From equations 1, 2, and 3, we obtain area of triangle AOB is equal to area of triangle BOC, which equals area of triangle COD, which is equal to area of triangle AOD. Therefore, it is evident that the diagonals of a parallelogram divide it into 4 triangles of equal area. Did you know? Heron, or hero of Alexandria, 1st century BCE, discovered the formula for the area of a triangle. He is best known in the history of mathematics for the formula which bears his name. Summary. Let us summarize what we have learned. Area of a figure is a number in some unit associated with the part of the plane enclosed by that figure. Two congruent figures have equal areas, but the converse need to be true. Two figures are said to be on the same base and between the same parallels if they have a common base, side, and the vertices or the vertex opposite to the common base of each figure lie on a line parallel to the base. Parallelograms on the same base or equal bases and between the same parallels are equal in area. Parallelograms on the same base or equal bases and having equal areas lie between the same parallels. If a parallelogram and a triangle are on the same base and between the same parallels, then area of the triangles is half the area of parallelogram. Triangles on the same base or equal bases and between the same parallels are equal in area. Area of a triangle is half the product of its base and the corresponding altitude. Triangles on the same base or equal bases and having equal areas lie between the same parallels. A median of a triangle divides it into two triangles of equal areas.